Okay, welcome everyone to AI Sweden's first AI Trends seminar. My name is Johanna Bergman and I'm Head of Strategic Initiatives at AI Sweden.
And my name is Anders Thoresson. I work as a storyteller at AI Sweden together with Johanna.
And AI Sweden is the National Center for Applied AI in Sweden, and we are our mission is to accelerate the use of AI for public and private sector in Sweden. And we are broadly funded by both public and private sector, national, neutral, non-profit, and
Yes. This is actually our first trend seminar, and we got lucky. The timing couldn't be better. Later today, Microsoft has invited to an event on AI in Redmond, and tomorrow, Google has invited to an event at their headquarters. And this is perhaps a telling sign of how hot AI is at the moment. And perhaps, Johanna, we have to invite on another trend seminar already on Friday to discuss what's being presented at those two events. As you can see on the agenda, we have a smackful 90 minutes ahead of us, and they are planned down to the minute. And we are going to make the best together with our guests to keep this schedule. But as it's so packed, we won't be able to take any questions from the audience today. Johanna and I have prepared questions that we want to ask the presenters and in the panel discussion at the end. But that doesn't mean that we are not interested in your questions. But we would like you to send them to us, reach out to us at AI Sweden, either through the chat function where we have colleagues who are answering questions, or by sending us an email or phone us afterwards. The idea with this event is to give you an insight in what the broad trends in AI are at the moment and what we think it's important to keep an eye on. And to help us framing this next 1.5 hours, we would like to introduce Daniel Gillblad onto the scene.
Yes, and Daniel is the co-director of AI Sweden,
Welcome,
one of
Daniel.
2 co-directors of AI Sweden, but also the director of Share at Chalmers, the Chalmers AI Center. And Daniel has played a central role in picking the topics for today, but also, probably most importantly, worked a lot on operationalizing AI in Swedish organizations for a very long time. So Daniel, the floor is yours.
Thank you so much. It's great to have this event at this kind of time, as Anders already said. Announcement after announcement on new capabilities and new opportunities within applying AI, and really cutting edge AI. Typically, when we talk cutting edge AI right now, we're talking large language models or generative models, etc. And of course, these things can actually answer some of these questions that we will bring up today, basically. So what are the latest trends within AI and so on? Of course, if you ask these kinds of models, it will tell you federated learning is important. NLP and large language models are super important. There are tons of new applications within healthcare, within automotive. We have to look more on adversarial AI and defending ourselves against attacks against these systems, learning systems that we're building. We need to focus on explainable AI. But basically, I think a lot of us sort of that live in this kind of context, we see these things and have seen these things floating around for a very long time. It's time to perhaps take a little bit of a step back and today start a discussion on and focus on beyond these kind of obvious topics, the slightly bigger pictures and the fundamental drivers that will drive AI in the future. So it's very difficult to say that, this is the direction everything is going to take at the moment. Just to give a little bit of a perspective, a couple of these things that we will perhaps touch upon a little bit today, large language models in terms of foundational models, a little bit of AI everywhere and decentralized AI and federated learning. It's important to note that a lot of this interest was sparked again. Some of these issues are older, but it was sparked around 2017, 2018 with new structures, new algorithms, new architectures that allow us to do what we're doing today. And this is not a long time, right? This is a really, really, really short time that in which we have developed new capabilities that are fantastic. At the same time, I really, really do think that if you start looking at the fundamental drivers of what we actually need to do to harness some of these capabilities of AI in the future, you can at least put together pieces of the puzzle and start drawing up a slightly larger picture. And of course, it's way more complicated than just saying that large language models will take this direction, decentralized AI will take that direction, because they all work together and they're all going to come together one way or another. But at least we can start think about, plan, and think about different kinds of scenarios, and also start thinking a little bit about what kind of scenarios do we want to end up in? Because I think it's a crucial time to start that discussion if it hasn't been started already, basically across society. So if we're talking about this rapidly changing landscape, what are some of the more fundamental drivers? Well, we have seen just during the last couple of years that new capabilities in especially the fields where AI can understand the world and communicate the world in terms similar to us humans, natural language, images, sound, video, etc., etc. Those are incredibly important to start automating something that perhaps 15 years ago we didn't really think about automating. We thought about perhaps automating processes and stuff like that, but now we're really also starting to look at automating knowledge work and creativity in a way that is kind of interesting and kind of scary, right? But these tools are going to be immensely important. Let's plan for them together with the other scenarios that we're talking about. And if we're building these large language models, these excellent generative models, for example, for video, images, and so on, it's becoming more and more clear something that we've always known when we're building large-scale or even small-scale AI systems, in that data is incredibly important. And not only having data, but working organically with data, extracting the data that we need, and actually feeding these systems what they need to actually learn. And we see these in all of these new developments that we're tweaking these things quite a lot with just feeding them the right stuff. And then we can also do the parallel of AI everywhere. So we can see when we are working, for example, within AI Sweden, that this type of data is not always going to be readily available. Some of it will be locked up in one place or another place. How do we make sure that we can build applications that can take care of these things? And also, how do we possibly avoid building silos? So of course, decentralization, distributed AI, distributed decision-making, all of these things will still be important. So we're going to work at scale in several ways, both the number of possible systems interacting, but also in the scale and capacity of the models. And a lot of these things are basically new perspectives on relatively old challenges in terms of things that we have worked on within the AI field: explainability, scalability, robustness, generalization. These are things that have been around forever, basically. But with each new development, we get a new perspective and how it fits into the bigger picture. So in combination with the fact that AI maturity within industry and public sector, and also a little bit amongst the general public, that AI maturity is increasing super rapidly. Not in all organizations, but many organizations are actually on the cusp of using some of these really, really cutting edge techniques and are really, really ready to build upon these things that we're seeing released just during these last few days. We are in a different situation now compared to just 3 years ago. And we need to put the pieces together because now things are really, really, really going to accelerate. And in part, we're going to have to look at the ecosystem a little bit differently. We have always talked, when we've been preparing all these large-scale AI efforts, AI centers and so on, like, we will develop and build AI. And we will continue to do that, but we will also become more and more consumers of AI. Of course, we've used AI before, but with these new type of capabilities, everyone is going to be a consumer in all kinds of applications everywhere. But also companies, organizations, etc., are going to build even more on other organizations' results, models, etc. So what does that actually mean for the complete ecosystems? Large models, large training efforts, large inference costs. How do we build these things together? Because now it's time to start thinking about not only where we're going, but again, where we want to go. How do we democratize AI? How do we make sure that this is a technology that we develop together for everyone?
Excellent, Daniel, and thanks for that introduction. I got one question that I would like to ask you now, and you touched upon it.
Yes.
You talked both about AI models and AI products, and this is a distinction that's important to understand, I think.
Right.
What's the difference between the two? So could you please?
Yeah, and this was perhaps 10 years ago a little bit easier. Almost always a model was a product. It did one thing. Nowadays, when we're looking at these things, there are these interactive language models. They're so generally capable that they can be used for so many things. Okay. So a product is more an adaptation of one or many potential models. So the whole ecosystem is going to look very different in just a year or two.
Excellent. You're going to be with us at the end again, but
Absolutely.
Now on to our external guests. And Johanna, come in again.
Thanks.
And with that, we are happy to introduce our first external guest today, Sasha Luccioni, research scientist at Hugging Face. And Hugging Face, for those of you who are not familiar with it, is a US company providing the most important platform for sharing open models and open data sets. And you are firm believers in that openness is a requirement for AI to have a democratizing effect on society, Sasha. The floor is yours.
Thank you. I hope everyone's good. I almost feel like I'm in Sweden. It's great to share this across the world with you. It's actually probably just as cold here in Canada as in Sweden. So I'm a research scientist at Hugging Face. I'll talk a little bit more about the company later, but I will start with democratization and what it means. So as many of our speakers will talk about today, AI is indeed everywhere in products, in applications, but it's an interesting question to think about who it belongs to. So especially in terms of big AI models, so especially big language models like GPT, like ChatGPT, have been disrupting, as they say, industries, especially in recent years and recent months. And it seems almost like there's a new model every couple of weeks or so. Except most of these models are from big tech companies, some now big startup companies, but it takes a lot of money, a lot of people power to train these big AI models. So it's creating a sort of digital divide in the sense of who has access to these capabilities or who can pay for accessing it. And so there have been some demos that have been free, but it's the no free lunch theory or the product theory. If you don't know what the product is, you're the product. So even these free demos typically either are gathering data, right, or improving their model somehow. So there's still, even if it's free, it's not really free. But if you want to train one of these models from scratch, in many cases, it's impossible because they're secret. I think they don't really share their data. They don't really share their approach. But even if you did have your own data, if you did have access to compute, to GPUs, it can typically take at least 1 to 2 weeks to train a language model at best case. It also takes dealing with GPUs, containers, APIs, so it's not that easy. So democratizing AI is an important part of this because it makes these technologies accessible outside of big tech, so to smaller companies, but also to governments, right, to non-governmental organizations, and to people who don't typically have the money or the skills to train these models from scratch. And that's why I joined Hugging Face over a year ago, because I truly believe that this is important, and it's going to become increasingly important as these models get bigger and more powerful. And so what is Hugging Face? AI community building the future. Actually, it's kind of a GitHub for AI. So if you know GitHub, it's a platform for sharing code and sharing models. And so the idea of Hugging Face is before you would, for example, if people published a scientific paper, they would have, for example, their GitHub repository with their models. Sometimes they would share their data, but it would be really hard to find these things, find these code bases. And when you did, you had to spend a lot of time getting it to run. Like this morning, actually, I spent a long time trying to get a bunch of models to run. And it's really hard. You need skills, you need time. And so Hugging Face is trying to bring all of this together and make it more seamless. And so, for example, we have a hub of models. We have over 130,000 public models for different tasks. I'll show you examples later, but typically, different things that you can do with AI, like image recognition, translation, things like that, speech recognition. We have connections to 40 libraries. So that means that even if you're, it's going to get a bit technical, but even if you like TensorFlow, but the model's in PyTorch, these are kind of different camps, different preferences. These models are compatible with a lot of them. So you don't need to, convert your code. You don't need to put in a lot of engineering work. We cover over 200 languages, including Swedish, I checked. And it looks something like this. So you can search for a task, search for a library that it's compatible with, search for a language, and then you get a list of models that you can work with. And then after that, it's literally 1 or 2 lines saying, from transformers, load GPT-2. And it loads it locally and you can use it. And actually now what a lot of people are doing nowadays is taking these models and fine tuning them. That means that you'll take GPT-2, which is trained on something very general like Wikipedia, and you'll take another data set that's, for example, relevant to you, something that's, for example, I don't know, if you're in finance, a financial data set, or if you're in medicine, a medical data set, and you'll fine tune, you'll keep training GPT-2 so that it fits your specific use case. And to that point, we also have a datasets hub. So it's actually the largest repository of ready-to-use datasets. That means that you don't need to do any cleaning, you don't need to do any labeling. They're very structured, they're very easy to load. So we have over 3,000 datasets, 450 languages, dialects, and this includes also code. So now people are actually training models on code to generate like code pilot stuff. And so we have that. And it's the same thing. So you say, I want to take GPT-2, I want it to do question answering, and I'm going to pick, for example, Squad is a question answering data set, and I'm going to continue training the model so that it can do question answering. But it can also be your data set. So a data set of, for example, medical questions that come from your company or your organization, and you keep training it. And my personal favorite part of Hugging Face is the demo aspect, because all this is cool, but you still need to download these models. You still need to make them run. It's still hard to showcase them. So we actually have what's called spaces, and it allows you to make demos of your model quite easy. And so, for example, you pick your model. In this case, it's an image classification model, and you essentially create a really easy interface where allowing people to, for example, drag and drop an image or enter some text and get a translation or answering a question. And that's really cool because that means that the user interface aspect is also kind of easy to do, and you can just like copy paste some buttons, copy paste some like elements, or for example, duplicate an existing space and then switch out the model or replace it with your own model. And that makes it easy to like create a demo in like a couple of minutes and then share it and say, hey, I trained a new model. It does question answering. Try it out, share it on Twitter, etc. And so I find that we're kind of really at a turning point in machine learning. So before, it used to be a very kind of specific skill that took a lot of practice. There's very few people who could do it. They were paid a lot of money, a very software engineering, and also limited to very specific regions of the world. And now, thanks to Hugging Face and also other actors, there's definitely other players in the space. Anyone with a browser or a graphical user interface can train and deploy an AI model, and that's pretty powerful for me because that means that slowly but surely we are decentralizing the power and the potential of AI. And so, to kind of resume. From my perspective, democratizing AI contributes to making it more diverse because, I mean, this would be a whole different presentation, but there have been documented cases where, you know, AI is not representative of many people, of many languages, of many contexts, right? We've seen AI models that, you know, discriminate against women or people of color. Like, we've seen that it happens. And it's not even necessarily always, I mean, actually, I like to believe that it's usually not on purpose, but it's just a question of diversity. People tend to care about things. I mean, this is one of our cognitive aspects of human beings. We care about things that are relevant to us. And so if the people creating AI are all from a given group, either a gender group or a country or, for example, linguistic group, like most of the AI models are for English, right? And that's not representative of the global population. And so democratizing AI and letting more people you know, handle these models, make them, appropriate them to themselves, contributes to making it more diverse. And so could be more languages, can be more populations, can be more geographical diversity, right? You know, there has been work saying that all of the image classification models that we currently have are very global north centric, and they will tend to recognize, for example, a car or a bus that looks like what we have in Europe or North America, but that, you know, buses look like different things in different countries, and these models work really bad on buses, for example, from other countries that are not represented. And so the more people that can use AI, the more diversity we can add to it just by, you know, giving people this potential. Also, this contributes to reducing biases and stereotypes. On one hand, by letting people study the models. So this is also something, I mean, that I do on a daily basis. I download models and I try to figure out how they work and how they work in edge cases and how they work in, you know, specific biases. And the more access you have to models, the more you can do this, because if a model is a black box, it's hard to study it because you don't really know what's going on under the hood. And also it contributes to improving AI because, you know, the more people who can do AI, the more we can build incrementally and share our results and reproduce each other's results and keep building on it. And that's kind of what science is. And if it's only a handful of small tech companies that are making this progress, this means that it's less transparent, and it's also harder to, you know, to build upon products that you don't have access to, right? I can't like take ChatGPT and make it better for my particular use case because I don't have access to ChatGPT because it's a black box. And so at Hugging Face, we have different people doing this. We have fundamental researchers like I am, who actually try to understand these models, document them, make them a little bit better from a I guess a scientific perspective. But we also have an amazing engineering team who, you know, I didn't mention, but like the back end to the hub is kind of magic because it makes all these conversions and it makes models easy to deploy, etc. We have developer advocates who connect to different communities and help them use AI and learn AI. We have custom AI solutions for businesses. So there's all this going on, and I really think that it contributes to making AI a more democratic affair. Thank you.
Thank you so much, Sasha. And it was a really good presentation on Hugging Face and your work. So I have one question to start with. We'll talk more to you in the panel later. But at AI Sweden, we just done a controlled pre-release of a GPT-3 model for Swedish at Hugging Face. And I'm a bit curious on your thoughts of smaller actors and smaller languages and the role that we can play in this when we see new large models released every day almost. What do you see? How do you see this role for smaller actors?
I think that there's power in community. And so whereas maybe big companies or general companies, they tend to kind of silo, you know, they will work on their own product and make it better, etc. But if there's smaller actors, there's less, like, for example, in your case, it's not to make money off of this model, just to make it kind of better and more accessible. So I think that there's a lot of power in connections. Like, for example, I contributed to training Bloom, which was like an open source language model that we, and it was like 1,000 people across the world who like volunteered their time and made this first open large language model. And I think that was kind of a great example of it's a lot of work and it's a lot of coordination, but in the end, you can make something that's just as good as these closed source models. So I believe in the power of community.
Thank you so much. And with that, we will introduce our next speaker, and that is Daniel Akenine from Microsoft. And you are the National Technology Officer at Microsoft Sweden, and will go deeper into foundation models from your perspective at Microsoft, and also touch upon the investment in OpenAI, I hope. So please, the floor is yours, Daniel.
Yes, okie dokie, thank you. So I have then 7 minutes to talk a little bit about foundation models and generative AI. So my name is Daniel. I work as something called the National Technology Officer at Microsoft in Sweden. So I work with new technology like AI, quantum computing, and other things that's on the horizon. So let's start. I think maybe we should do some kind of an introduction on the concepts, because sometimes when you see this kind of hype of new technology coming up, there also gets a lot of confusion. What does this really mean, and how does the definitions look like? And also, I think in many cases, these definitions are not necessarily super clear, to be honest. They are kind of an idea of what we actually are talking about. But when we're talking about foundation models in this context, it is basically some very big artificial model of AI model, which is trained on a big quantity of data, which is not necessarily super focused on a specific use case, but something that you can use in other areas or other domains. So it's more flexible than maybe this super trained models that are used for a specific purpose. And then you have the other term that has been super popular these days, which is generative AI. And generative AI is related, but it's more algorithms that's used to create content, to create more information, if that's pictures, or if that's text or something else. But it actually is something that gets created from a foundation model, for instance. It could possibly be created from something else as well. And this is something that has been very fast the last couple of years. So if you look at it for the last 5 or 6 years, when you try to understand how fast does AI move, you try to compare it with human capabilities. So are your AI algorithm as good or better in producing a result that a human could do, especially in this more complex cognitive use cases? And what we have been seeing the last 5-6 years is a rapid development in that. So in 2016, we saw human parity when it came to a test called ResNet vision test. So how do you categorize and understand pictures from an AI perspective versus a human? Better or parity. So you had in 2018, you had something called a scored reading comprehension test that is reading, interpreting text and can answer questions from that text. Human parity 2018 or better, which is something we now also see an accelerating capability in. 2018 machine translation, human parity. 2017 human parity in understanding what people is saying. So what we're having here is a lot of different AI algorithms that are as good or better than humans in a lot of those areas that we couldn't do digitalization before, and that matters when it comes to using these in new areas. When it comes to generative AI models, so what we are seeing is a number of different foundation models that can be used to create an application layer above. And even if it's OpenAI and GPT-3 that we're hearing a lot about, there are a number of other foundation models as well. And they are focused to some extent on a specific domain. So if it's about text, they have been trained on text. It could be code, so it's trained on code. It could be images, so it's trained on images. So it has a specific domain, even if it's quite broad in that domain. So what is happening is that you get a lot of capabilities that you can build applications on top on. And that's what we are seeing happening now quite rapidly. So you could, for instance, use these foundation models like GPT-3, etc., to create the marketing applications, sales of the, applications. You could do note taking, for instance, etc., or code generation. So if you're a coder, so you're seeing, and this is something I think we will have the next couple of years or the next year, 2023, you will see much more of those applications being created. But is this useful then? Does this really matter? Does it have a huge impact? And if you look at some of these applications, for instance, like GitHub Copilot, which is an AI system that is helping you to code from all of the code that's existing already. It gets knowledge from that and it helps you. So if you ask a programmer that is using GitHub Copilot, are you more productive? So 9 out of 10 says yes. I feel I'm more productive in my work. 6 out of 10 says I'm less frustrated. I'm more fulfilled with my work. And 3 out of 4 say, well, now I can focus on more satisfying work. So yes, it matters. These numbers to some extent are huge. So I don't think we necessarily will see future programmers being alone and not being able to use this technology. You have to use it to be a successful programmer. So yes. So I was also asked to talk a little bit about what Microsoft is doing with OpenAI from AI Sweden's perspective. And I think you might have seen, it was actually a couple of years ago, Microsoft did a big investment in OpenAI. I think it was $1 billion. And a couple of weeks ago, we announced a new extended partnership as well with OpenAI. But does that mean really? So what does the collaboration mean? Well, it basically means 3 things. It means that Microsoft will supply the supercomputing resources for OpenAI through the Azure stack, basically, to help OpenAI do research and accelerate their research as well. It's taking a lot of compute resources to train these foundation models. So it's necessary to have this kind of hardware. We will also actually deploy a lot of the OpenAI experiences and foundation models into Microsoft products. So that's something else that we announced. And we will be, in this case, then the exclusive cloud provider to a lot of different other areas that OpenAI is working on as well. So I would like to finish up a little bit just with one slide. So I asked, does this matter? So I think from a productivity perspective, yes, it's obvious. But you will also see some kind of new societal effects here, which are interesting. So I was at something called the Handelshögskolan in Stockholm last week, and I talked to them, and the principal there, Lars, actually wrote a debate article on how should this type of new AI impact the university system, like Handelshögskolan, for instance. And there are arguments for banning this technology, obviously because it can be used for cheating and plagiarism, because it generates text that you as a student should be generating. You should not ask things, you should generate answers to questions, not necessarily just questions. But there are arguments against. It's an important tool for learning. It will be an important tool for learning in the future. So why don't you use it in the learning process as well? And if you can't stop it, then it becomes very complex. Do you need this type of traditional education if you are just working with a lot of AI systems surrounding you? And maybe you should refocus what you do from knowledge to something else. It could be self-esteem, it could be good judgment, or things like that. So I'm just wanting to bring up this kind of last slide to also say that this is not a super easy thing. It's going to impact not necessarily only business or AI research, this is going to impact a lot of other areas as well in the future. So, thank you.
Thank you, Daniel. You touch upon what the other Daniel Gillblad and I talked about in the beginning, the difference between the foundational models and the AI models and the products that are built upon them. For the organizations represented in the audience today who don't work actively with developing the core models, the foundational models, but want to build AI-enhanced products and services, what can you tell about how that process looks like, taking a foundation model and building a product on top of it?
Well, I think if you look at I took the example of CodePilot, for instance, where you could see the productivity for a coder. What hasn't been as used is how, if you look at other areas, could you achieve the same productivity if you are a lawyer, for instance? Could you achieve the same productivity if you're an editor of a book, for instance? The answer is probably yes, or almost yes to that question. So that is areas that hasn't been so much in focus yet. So I think in areas like that, using, for instance, ChatGPT or other models as well, that will be a revolution of models, I think, for the next years to come, to understand the context where you're going to use that and deliver knowledge on top of that is something I think is open for everyone that wants to develop this area.
But does that also mean that you can look into other verticals and looking what are they doing with AI, not only looking at the companies and organizations that you compete directly with to get inspiration, but also look into other areas, because the foundational models allow for fine-tuning for different things. And once you understand it for one vertical, you can get inspiration from that.
Yes, it's about refining. So one example would be Domstolsverket in Sweden. So they have been using AI for translations, and they're not necessarily using the general translations because they have so many special words and special meanings. So they have to refine the existing translation models for their context. So they have done that, and they are super happy. I think they have 90% cost savings compared to it. So you can always find these fantastic use cases when you refine things.
Yeah, excellent. Daniel, thanks for being with us, and you will join us for the panel discussion at the end as well. And with that, we move on and turn our interest to where the AI is actually executed in the cloud or on the edge, distributed on devices of different kinds. I would like to introduce Ted Schönbeck, who is head of cloud technology and will talk about AI everywhere. Welcome, Ted. And there you are, Ted. Hey. And you're sharing the wrong screen, but you are at it, I see. Yeah.
Sharing the right screen?
Excellent, yes. Thank you.
Okay, so let's get started. Thank you. So yeah, my name is Ted Schönbeck. I head up the tech org for Google Cloud in Sweden. And as we already heard, 2023 is off to an amazing start when it comes to AI, with all of these amazing chatbots and picture AI generators. And actually, most of the pictures on the coming slides was actually created using an internal AI bot that we have. So off to a really exciting start. But AI is already happening everywhere, and I think we're going to see an explosive growth of that in 2023. And the way we're seeing this is a few different changes. So it's about kind of pushing AI to the edge, and this involves changing the way you build and develop your use cases, but also I think using some new technologies. And simply put, the overall theme here is, you build, train, and create your models in the cloud, and then you execute them at the edge. That's really, I think, part of the secret here. And I'm going to talk a little bit about how we can help you simplify that, and then I'm going to dive into a few examples. And then in the end, I just have to give one of my favorite examples on AI that I was involved in myself during 2022. But let's get started. So first of all, I think we touched upon it already a little bit, how can we simplify getting started with AI? And I think TensorFlow creates an excellent foundation for that, a complete AI and machine learning framework, developed by Google, but open sourced by Google, and today more or less industry standard for many when it comes to doing this. But building and training your models demands a lot of resources. And Google, we detected this ourselves in our own platforms. So we created our own hardware to do this, called TPUs, or tensor processing units, designed to crunch TensorFlow commands and can do this super efficiently, right? So this creates a great foundation for start to build and run your applications or your machine learning models. But when you want to apply them at the edge, a lot of organizations are challenged. So TensorFlow works great, but finding the right architecture and platform to do this is often challenging. So we decided to help out by bringing our TPUs to the edge in something we call edge TPUs, the size of your fingernail. This gives you the opportunity to have the same architecture running at the edge, so it's easier to apply the models at the edge. So you don't have to send data back and forth, right? So let's look at a few examples of this. The first example I want to give you is in manufacturing with LG C&S, one of the world's largest manufacturer of OLED and LED screens. And they were really trying to solve the problem of error detection in production. Problem is 200 pictures per second per production line is just too much to have the time to send to cloud and analyze. So they built and trained the models in the cloud and then applied them in the factories using edge TPUs inside cameras, really helping them, increase error detection, and by that, saving a lot of money. Another example is from our own sister company called Wing. I'm not sure how many of you are familiar with Wing, but they are already present and doing drone deliveries in the US, in Canada, in Australia, and actually doing testing in Finland and working together with companies like Walgreens and FedEx to do drone delivery. And doing these drones, you really have to have totally autonomous drones that can act independently and change depending on surroundings and weather and act on demand. And again, a lot of different sensors on these that you train models for in the cloud, and then you put edge TPUs and at the edge executing those autonomously from the cloud. What about consumers, us? Can we get close to this new type of technology? Well, you can actually in Pixel phones, where we are bringing the exact same TPU architecture into our custom-built silicon inside mobile phones. So, well, first of all, you get a mobile phone that's smarter and easier to use, but we can really do some offline magic using something we call a private compute core. This gives you the opportunity to do really cool AI magic on the device without connecting to the internet. And let me show you a few examples. The first one, music identification. Just put your phone on the desk or a table, and it will listen to music around it and present the song and the artist on the always-on display. Completely happening on the device, no connection to the internet. Same thing for translations, using your phone as a translator, talking to someone and having the entire conversation being translated on the device, no connection with the internet. Now, obviously, this creates a great experience from a consumer perspective, but it's also about privacy, obviously. And this is only possible because of what we can achieve using those TPUs at the edge, really crunching through those algorithms much more efficiently. The last example, as I said, maybe not an edge example, but an example of how AI really is spreading and I think creating cool experiences that we might not think are powered by AI. This is a large global fashion retailer, and because this seminar is being streamed online, I'm not allowed to say the name of it, but hopefully soon. But the cool thing here, what they were doing is they're using pre-trained vision APIs from Google. And these vision APIs are super powerful, being able to get detailed information out of pictures, really detailed information. So they're using these vision APIs to crawl the internet, checking fashion influencers, fashion bloggers, fashion news, fashion medias to see what type of clothes and styles, colors are trending and where. This feeds into an analytics and machine learning engine, and they use this across a few really cool use cases. First of all, if you go to their e-commerce website, they will push clothes to the front end depending on where you come from. So it's going to be stuff that's trending where you come from. In Stockholm, London, or New York. Same thing in the physical stores, pushing the right stuff to the shop windows in the actual stores, creating a better experience. And on top of that, using this for inventory optimization, making sure that the right clothes are in stock at the right places, creating better experience, better sales, but also sustainability, right? Because you're not shipping around clothes that not sells. Last but not least, they are famous for being really quick to market, being able to go from design to store in 6 to 8 weeks, which is really impressive in this industry. So they're using this data to feed into the design studios, to create clothes, to follow trends, and have it out in the market in the right place at the right time. A really cool use case, I think, for AI, where you just experience a better experience without knowing AI is there. But as said, 2023 is going to be an amazing year for AI. Yesterday, we introduced Google Bard, which is 7 years of research from transformer large language models 7 years ago, now coming into play across chat robots, developer APIs. We're even going to include it in Google Search. But the really cool thing here is how we're going to bring this to Google Cloud so that every organization is going to get access to this, fueling and supercharging all of our different products and services. And actually already tomorrow, as Anders said initially, we're going to do the first announcement of how we are bringing this to our products to help you all start building cool things with AI. Thank you.
Thank you so much, Ted, and exciting to listening tomorrow and see what's happening. So you gave some examples of how AI on the edge can give competitive advantages, but could you please give us some more details on the general benefits on AI on the edge? Why should you use AI on the edge instead of a centralized way?
So I think it comes down to several things, but just all of those type of use cases where you have large data sets, it's just not feasible to transport it back and forth between clouds, right? I think that's one of them. But also use cases where you might not have a secure internet connection, but you still want to be able to do it. And last but not least, from a privacy perspective, being able to do things, at the edge without connection to internet. I think Daniel mentioned it, like doing translations in public sector, being able to do those translations, on-prem without, being reliant on cloud providers, etc. So I think it's everything from legislation to just data and bandwidth capacity, which I think is an important part of the edge use cases.
And building on to that, when do you think we should not use edge AI? When is it better to use the centralized way?
Yeah, so obviously edge is always going to be a bit of a challenge. So definitely when you build and train your models, huge models, just looking at whatever all of these models, the amount of data that you have to train them, obviously you should definitely do in the cloud. But also, you have a lot of solutions that you can provide, different type of web user interfaces, chatbots, customer services bots, all of these use cases where you are not relying on stuff happening at the edge, where people can connect to the big data centers and just consume it. But specifically, I think the development and training is perfect to do centrally in these, where the hyperscalers can provide, infinite resources to get you trained on the models.
Looking into the future, how do you think that the cloud versus edge will develop?
I think it will always be both, and I think there's a lot of discussion on this, with a lot of different kind of forces at play, where a lot of the traditional telco providers wants to bring more and more to the edge, giving them, the ability to do that. I think we're seeing, and hopefully we will hear a bit more in the next speech, on autonomous cars, autonomous trucks, autonomous driving, where you definitely need to be able to act at the edge. Because you cannot rely on internet connections. So I think the entire era of autonomous things is going to drive a lot of edge use cases, I think. And also I think, moving into smarter stores, grocery stores without cashiers. And we've seen Amazon do really cool stuff in the US on that, where you just have cameras and you just go in and you take your stuff, put it in your backpack and go out. And you have AI really, analyzing what's going on. So I think there's going to be a bit of both for all of this, definitely.
Good. Thank you so much, Ted. And we see you soon in the panel.
Yep.
And our last speaker, we have Anders Bell, that is Head of Global Engineering at Volvo Cars. And unfortunately, his agenda didn't allow for live participation. But he recorded a presentation and conversation together with Anders last week, and we will look into that now.
And finally, as our last speaker in this event tonight, we have Anders Bell, Head of Engineering at Volvo Cars. Welcome, Anders, and the floor is yours.
Thank you so much for the introduction, and thank you for having me. We truly live in exciting times, and it's looks like it's going to be exciting for quite some time ahead. On AI, today I will touch on some key trends in the field of AI and some thoughts of what AI will mean to us in the automotive industry. There are several definitions of AI, and going further in this talk, I will define AI as a system capable of perception, reasoning, and actions to achieve certain goals. And in that context, AI can be described as a family of tools which can help us with both physical and cognitive work. And the purpose of AI is, in this context, furthermore, is to amplify human intelligence and capabilities as an extension of the human capabilities. In the last decade, we have seen huge improvements in the AI capabilities, where two of the most significant recent advances have been in generative models and reinforcement learning. On generative models, language models that many of you, including myself, I'm sure have interacted with and through on ChatGPT is a form of generative models that have been trained on large internet-sized sets of data and can generate text and code. And other generative models, as you see in this interesting take on a Volvo EX90, can generate drawings, images, and more. And furthermore, reinforcement learning is a way to train AI. For example, we use it to train autonomous cars to make safe driving decisions and avoid collisions, or more kind of grounded applications, for instance, controlling systems for manufacturing processes. It could be controlling a furnace, temperature of a furnace or furnace system, or speed of a conveyor belt used in production. So it's important to notice that while progress on AI on applications seem revolutionary from the outside, in the cases of ChatGPT, for instance, for the outside observer, looks like it's coming from nowhere, but it's obviously a continuous progression for the people in the field. The recent advances in language models and text-to-image models were made possible by access to huge sets of data, and combine that with rapid improvements in self-supervised learning and transformers. These techniques have been developed over a number of years and have had a big impact on a short time on the AI community and opened a range of new possibilities. Many companies use these techniques already behind the scenes in applications that we use every day, in translation, content moderation, speech recognition, and so on. And recently, some of these models have been open sourced to the wider public for everybody to use. In autonomous driving applications, our AI models needs to be grounded in the physical world and to be able to interact with it. This is a huge challenge, and the automotive industry will continue to play a crucial role in this driving this development. Having the vehicle, which is a 2 to 3 ton piece of consumer goods, navigating through real-world traffic conditions where other humans are present, obviously puts a very high level of requirements on our products. One of the challenges we have is to give the AI the ability to learn and accumulate background knowledge through observation. This would be like how humans and animals learn in their early weeks of life, where we can learn without labels if we observe long enough. The general form of this is self-supervised learning, which we have to some understanding of with text, but must develop further to become applicable to images and videos. And to scale, which is important, to scale this up, we need to reduce our dependency on labeling these images and videos. Second challenge is to improve the reasoning and planning abilities in AI systems. And so as similar to humans, when we as humans have a goal, we figure out the steps and achieve the goals in an iterative process. And similarly, we need to give the AI the ability to elaborate on an answer through a process where it reasons its way through the problem. So in summary, we are continuously equipping our products, our cars, with ever more powerful sensors, computing powers, and telematics. And the purpose of this could be ranging from reducing traffic risk through active safety, improving protection and mitigation in the case of an incident we cannot avoid on the roads, or simply make the users or the customers' lives more convenient. The vastness of the data we are collecting and we can access will require AI and machine learning to comprehend and turn and transform into knowledge. That knowledge in turn helps us to develop the superpowers we need to pursue human goals, such as improving transport safety or battle climate change. And overall, the distributed learning we are developing at AI Sweden and together with other partners will be absolute necessary means to get there. And then ending with the usual disclaimer that obviously we will do all of this in compliance with all privacy regulations. Thank you very much.
Thank you very much for your presentation, Anders. And I would like to start with asking you a question. As you said, you are 6 weeks into your new role as head of engineering at Volvo Cars. But what are your overarching vision for how AI could be used in a strategic way for Volvo Cars?
I think we need to play both the short and the long game at the same time. Primarily, we need to prepare for scale. We need to do the basics and develop the structure in which to collect the data, organize the data, and make data accessible. So we avoid creating data silos and preparing for the very near future when we have a full insight to the infinite complexity of the real world through the vehicles on our roads. And long game obviously is developing the skills and competence required to design and define the systems needed to comprehend that data. I think there are so many use cases ranging from safely driving and navigating a car through city traffic to understanding smaller aspects of customer behavior and product usages. So I think the application side, we're just kind of scratching the stage. It's almost like the imagination of the human mind is not enough to imagine the use cases in the future we will have, and the way all the learnings we will get from the data insight we will have in the future.
With all these vast numbers of possible applications, could you say and tell the audience anything about how do you prioritize between use cases when there are so many to choose from?
So safety is the leading, the tip of the spear in all data collection and real world comprehension and AI application for sure. And the typical area of safety is autonomous driving and active safety, which are obviously closely related. But I think what the full understanding and full comprehension of again the infinite complexities of the real world will allow us to improve every single aspect of safety, not just the traditional, which is in this case traditional for discussing AI, active safety, what's going on outside the vehicle, but truly understand how the exposure on the roads change as our active safety systems become ever more powerful and better, and also be able to understand and develop how our vehicles should react in the absolute best appropriate way whenever incidents that we cannot avoid will incur, because they will keep on incurring for sure. Even if our car can avoid all accidents, there will be a mixed traffic for many years where we'll still be hit by others.
Yeah.
And understanding how that exposure shifts and gradually adapt to it.
Excellent. One final question. How do you build end user trust in a future where autonomous driving is a part of everyday life?
And that's pretty straightforward, really. We need to design and deliver performance and have clear evidence of that performance and present that openly.
Yeah. So once that you can prove that your cars are safer when driven by AI than by a human, then it will sell itself.
Absolutely. The answer is a bit more complicated than that, but in the interest of time, we can take that maybe the next year.
Yeah, super. Anders Bell, thank you for joining us in a pre-recording tonight, and looking forward to talk to you in some other circumstances in the future. Thanks for now.
Thank you so much. Take care.
And with that, we have heard our four guests on the topics of tonight: democratizing AI, foundational models, AI everywhere, and progress in applied AI. And we are now going to continue with a panel discussion with all our guests who are with us live today. That means that Anders Bell is not with us for a panel discussion, but instead, I'm also very happy to introduce Caroline Jacobson from Ericsson, Head of System Management at Ericsson's Global AI Accelerator, Gaia. Welcome to the discussion, Caroline. And I think that we want to start with you, Caroline, really. And I'm interested in, from Ericsson's perspective, being a company just like Volvo Cars that works a lot with applying AI in different products and services. What are your reflections on what we have been discussing so far tonight?
Yeah, thank you very much, Anders, and thank you everyone for very interesting presentations, I think, on the trends, which are important for us in Ericsson as well. So basically, if we start from the end with applied AI, I think that if we look at the future industry needs, they will have huge demand on our telecommunication network. You can have, for example, remote surgery. You want the best doctor on the other side of the world. Or we are also foreseeing that we will have physical and digital worlds that are converging. So we need like to sense a robot in a factory, for example, and place it in the digital three-dimensional factory. To manage with that, we need really reliable networks with very low delays, and they can handle high throughput when needed. We cannot always give that service to everyone. So to manage with that, we need to enhance functionality a lot. And we are using then AI as a very important tool to succeed with that. But I think also what Ted talked about, AI everywhere, is very important for us, because when we are optimizing the radio, we are steering on every millisecond. So we need really fast control loops, meaning we cannot handle it in the cloud. We need to do it on the edge. And we have really complex AI problem also on the edge, but quite limited than compute and memory to be able to handle it. So that's an interesting challenge, I would say. But even then, if we think that we have like limited compute, it's still so that if you compare maybe to some devices like helmets, for example, for bicycles, we could offload them because we are like everywhere on Earth, more or less. And compared to those devices, we still have quite a lot of power, so we can help them get smarter, better. Then I was thinking also a little bit about democratizing AI, and I think everything Sasha said is interesting. I was looking upon it also, how do we do it like internally? And I think we need to get it in everywhere in our products, more or less. And for that, we need to start innovating. And engineers, as you know, love that. But what do we have to do then? We have to make the data obviously available so they can start experimenting for a faster journey. I think we also need like compute and machine learning pipelines internally. And we need to, instead of models, maybe we even more need telecom experts that meet the data scientists for a fast progress. And then when it comes to the last one, the foundation model, as Daniel say, we are tuning the language models with telecom specific text to make it efficient for a large number of needs internally.
Thank you, Caroline, for that initial reflections. And now, Johanna, on to the panel discussion.
Yes, and I think we start with you, Sasha. So we talked a lot about models and model sharing today. You touched upon data sharing as well. But how does data and model sharing relate to each other? And do you see that one is more important than the other?
Well, I think it's hard. It's a chicken and egg problem. I think that data, well, you can get models from data, but you can't get data from models. So it's like when you ask an archaeologist, it's like the chicken or the egg, and they're like, well, actually they're all dinosaurs. It's kind of like that. I would say that the data is more important because it allows you to train models. And I mean, yeah, we have some techniques that are kind of a bit secret, like the current instructional language models like ChatGPT. You kind of don't really know what they're doing, but the secret to those are actually is actually data as well. I mean, people say that they've gathered a lot of human interaction data. So I think that sharing data and documenting it as well, not just sharing kind of like whatever, but making it clear what's in there, where the sources are, what the metadata is, things like that, is really the key to more democratic AI.
Yeah, thank you so much. And Google and Microsoft, you both publish models on Hugging Face. And so Daniel and Ted, what is the motivation behind publishing models openly as well? And how is the reasoning behind that? We can start with you, Ted.
Yeah, so I think overall, Google is passionate about open source overall, and I think just sharing models and sharing data, and I think we're also sharing a lot of results that we've achieved, with everything from protein folding to other things that Google shares or DeepMind shares. But I think it's two parts to it. One of them is when you're sharing models, you get input to those models and you get insights into those models. It becomes a little bit a survival of the fittest scenario. If the model is good, it flies. If the model is not good, people will not use it. So I think there's an element of testing and trying and driving innovation. And then I think the other aspect is definitely ethics and democratization. And I think AI is such a powerful tool. I think it's dangerous if we limit ourselves that to a few people to have it. So I think it feeds into our AI ethics agenda of sharing it. So I think it's twofold. One part is getting better models. The other part is also staying true to our values on AI ethics.
And what do you say, Daniel?
Yeah, I think from Microsoft perspective, we are both using, and producing open models as well as closed models. And I think in some ways it's a little bit like open source on how you actually work with open source as well. Sometimes this is the way to move forward, and sometimes it's basically a business decision to maybe keep the IP or try to do an edge thing with some of the code. And I think that's part of the innovation process. I see that in other areas as well that I'm covering, like for instance in quantum computing. I see we are in an area where you share a lot. So you share a lot of the research, you share a lot of what's happening. And the reason for that is to move quickly as a community, quickly on the innovation. So and then you come to a certain point where people is trying to create some kind of edge. Maybe you have some kind of knowledge, you do some kind of product that is gets an edge. So if you don't collaborate, you will probably move much slower as the community. So I think that's you're seeing that in AI, you're seeing that in open source, you're seeing that in basically every area. So I think it comes with the modern way of doing business, actually.
Thank you. And Caroline, I think it's really interesting to listen to what Ericsson's view on this is. So how are you thinking, and what are your strategies when it comes to model and data sharing? And do you have a discussion on what type of models to share or not? And or how does it look at Ericsson?
I mean, generally, sharing has always been a very important part in the telecommunication ecosystem. And the reason for that is that we want like worldwide services that works for everyone. I mean, you expect the phone to work when you're traveling, and the self-driving cars, they are crossing borders, obviously. And the way we do it is that we use standardizations and patent to balance quite the huge R&D effort that is needed, but still making it available for everyone. So the ones with patents have to offer them like in a fair and equal for all terms. And that also hinders in a quite a good way lock-in effects, because the different vendors can be replaced by each other, which is good then for our customer, I think. Also, it makes like the ecosystem increasing, which means that it speeds up innovation, but also it reduces prices. So we can actually have a good telecommunication network at the villages in Africa, which makes a huge difference. And so what we're doing for AI now is that we are standardizing that part. So AI gets in the support we need. But what also is happening is that our customers want a little bit more flexibility, openness going forward. So we have a new open architecture that will allow different organizations or actually individuals to help develop applications that can steer and impact the networks further.
Anders Bell, in his recorded presentation, touched upon how it seems like we are taking really big steps forward right now with ChatGPT and other models, but in reality, it's more of a progression that's insiders could anticipate, but outsiders not being a part of the development are quite shocked by it. And we can see that in the reactions to ChatGPT, where some organizations are really afraid, just like you showed, Daniel, with higher education, for instance. What does this mean to us, while others marvel at the opportunities? And I think, Sasha, that this could also somewhat be seen as a democratizing aspect of AI, understanding and being prepared for what's about to come. How do you think about that at Hugging Face?
So I feel that we're always playing catch up, because a new model comes out, someone uploads it, and sometimes we get a 24-hour notice, like for Stable Diffusion, we got a little bit of notice, but most of the time it's like, oh, there's this model, we have to figure out how to document it. I think it's more of an issue of documentation and awareness of limitations. So the thing is with ChatGPT and other API-based models is that there's no way of documenting how they work. Like ChatGPT can be one single model, but it could also be 8 different models or humans in the loop. You don't really know, and so it's really hard to say. Or even like it can evolve over time, and it probably is evolving over time. People are saying that it's getting better, at responding to certain prompts, and so it makes studying these models really hard. And so I mean, I would love to try to do a study saying, okay, this is these are some failure cases, these are some opportunities, like this is how to detect machine generated text by ChatGPT. But in order to do that as a scientist, you need to know what you're working with, because if it keeps changing and then you train a model to detect, for example, generated content, and then all of a sudden the model changes, you need to know that, or otherwise it's not apples and apples. And so I think that the more models get shared, the better we can do research essentially and present our results. And for example, carry out techniques like watermarking. It's becoming an important thing, like how to invisibly mark content that's been machine generated, either images or text or video or speech or anything. So this is like something that needs to be figured out now before, you know, someone, I mean, people are already doing this, sharing images saying, oh, well, this politician is doing something, right? And then it's hard to prove either way. Or, you know, somebody wrote this text, etc. And so I think that in order to make it possible to do safety things like that, you need to get access. And so it's kind of, once again, a chicken and egg situation.
Well, once again, the egg and chicken, Carolina, inside Ericsson, how are you working to prepare your organization for the present and not the least the coming development within AI, so that you can act accordingly when new models are available to you?
Yeah, so we have a central organization which I'm part of, and our role is to help the rest of the company to figure out how and when to use AI. So we are probing what's happening in market and academia and trying to take in the new technology at the right time. I mean, it has to be technology potential that meets the product needs at the right time. And then we start experimenting. And I think that's very important to understand when does it give gain, but also what do you need to get it going. It's a little bit seeing is believing. And to understand also what do you need to make it work at scale in your products. That's a little bit more complicated. So I think it's a bit interesting because for us, AI is like an interesting journey. There are many steps you have to take. So it's not like one big transformation and then you're done. It's like continuous investments in the right direction that is needed. So I think companies need to start to travel.
Daniel, how can Microsoft help the company's customers to get prepared for what's coming, for what you are launching together or presenting together with OpenAI later today, for instance, or what you just have told the world about how GPT will be applied within the Teams suite, for instance?
Well, in the case of ChatGPT, it was obviously extremely fast. And if you look at what's going to happen now is that we are going to even accelerate that, because you're taking the, just a little bit of a playing with ChatGPT into products that already have big adoption. So if you take Google search or Bing search or Word or Teams, and you apply this kind of technology, suddenly you have 100 million users in a week. So, and they are using it as well. So it will have a lot of dramatic effects very quickly. So how can you be ready on that? Can you? It's so I think the persons that are listening to this, chat, you are one of the marginal percent that has some clue that it's going to happen. But if you look at the kind of the broader society, they have absolutely no clue. So it means you have to be reactive, because it's so difficult to be proactive in this area, I think. And that's a little bit of the way that innovation works. So you can try to be proactive, but it's very few organizations that have that possibility, I think.
But is there a chance for us on a societal level to be proactive here, or how do you think about that, Daniel?
Well, on a longer term, yes. So if you are looking at the EU, for instance, they are trying to regulate AI. So they are trying to be proactive on the use of technology, but we're already seeing how the technology in itself kind of impacts the regulation. So the regulation didn't realize about this ChatGPT or this, more general AI system, etc. Now it's trying to adopt. So it's difficult to have the same speed in the environment as the technology by itself. You can do your best, but you can never be perfect in that, I think.
I think. Ted, what's your thought on this, helping organizations be prepared for what you are launching tomorrow, for instance?
Yeah, I think overall, every big technology shift has the opportunity to create, amazing things, but also creating fear. And coming back to what Daniel touched upon, with legislation will always be behind technology. That's the only thing. That's the only way it can be, and we need to help legislators push through. And think Daniel and I are working on this every day with public sector, and then making small progress every day, and we see it here as well. But when it comes to enable organizations, I think one thing that we've been trying to do is to I think we got it wrong a few years back when we always kept training and evangelizing about AI with technical parts of organizations. Because at the end of the day, it's not the technical part of the organization that kind of come up with the ideas. So I think we're starting really to work with, everyone in an organization, the people at their desks, the people in the stores, the people on the field, to help them understand the potential of AI and what it could do for them. And then they come up with the ideas and they go to the tech org to help them solve the problem. But I think, so I think one part is definitely evangelizing broadly about AI and its potential, not just to tech people, but to everyone. And when you do that, talk in a language and a model that everyone understands, and everyone will see the potential instead of the fear of AI. So I think that's something we are doing a lot of right now.
Thank you.
And to finish this panel, you all will get... Oh, some echo? No? Okay, you will get 30 seconds to just give your thoughts on how the topics we talked about today will generate real value in organizations around the world. So I think we start with Sasha.
Thanks. I can't talk much about business value, but I do believe that learning about AI and de-dramatizing AI a little bit, democratizing AI is important, even for people who don't use it in their daily lives, for general literacy and comfort. I mean, people should be aware. It's kind of like, the new web AI. And I think that generally speaking, the more people outside of tech are comfortable with it, the more we'll see new applications emerge in marketing and in anything, right? Any fields, and that will, feed back into it and will make it a bit more diverse as a field.
Thank you so much. Moving on to you, Caroline.
Yeah, so I think it's like endless possibilities, and I think people should start to try it out. And I mean, maybe foundation model will be your new buddy if you're a programmer or decision maker, for example. I think we will see a lot of application for safety, like the helmets or robots taking care of blasts in mine. But also a lot of repetitive work that disappears, so you can use your time to be creative and innovate and have fun, basically.
And Daniel.
Yeah, I talked a little bit about that in the speech as well, and I think that one of the things that AI will do is to accelerate the digital transformation in many companies. And it sounds a little bit of a cliche saying that, but the reason here is that we have so many black holes in our companies that we haven't been able to digitalize. And AI comes like a savior and says, well, here is a new area that you suddenly could digitalize. Maybe you want to be more productive, or maybe you want to create a new product there. So there is a lot of opportunities to kind of re-engage in this digitalization journey that has been around for many years. More power to that transformation, really. That's AI.
Yes, and Ted, finally your thoughts on the real value.
Yeah, no, I agree with what everyone said. I think overall, both data analytics and AI is already transforming businesses. I think what we're going to see this year is how it becomes even more accessible to people and everyone. And as Daniel said, I think that will be creating an amazing foundation for digital transformation. But I also think we're going to see massive value in society. I always reflect. I have 3 kids, age 10, 13, and 15, and I always reflect on the fact that the way they go to school is very similar to the way I went to school 40 years ago. And I think, a lot of these technologies will transform and make school and learning completely different and more exciting and more preparing, the children for the future in a completely different way. So I see even bigger, opportunities there, actually.
Right. Caroline, Sasha, Ted, and Daniel, thanks a lot, and also to Anders Bell for joining us tonight and sharing your thoughts on those 4 AI trends. Hope to talk to you again some other time, but now we're going to wrap this up together with Daniel Gillblad at AI Sweden. So please, Daniel, join us again. An initial reaction and thought about the discussion and the presentations. What do you think are the core things to take away?
I think some of the core things to take away is the fact that we're on the cusp of actually scaling AI in all kinds of directions now. Decentralized, bigger models, more impact. AI is accelerating itself basically at the moment. And that's I think is a core takeaway. I think it's very, very interesting to think about what that means for the new type of infrastructure, for the new type of ecosystem that we're going to live in and with for AI.
So what are your thoughts on the question I asked the panel? How do you prepare for something that moves so fast?
Yeah, I don't think you can fully prepare, but I think you can do a couple of things. Stay up to date through other people, because there are tons of people that are focused on different things, and many of them are really, really good at explaining those concepts to you. So stay in touch with lots of people that can help out. And that's I think is a really, really good thing. But also try to look at the bigger driving forces and plan for the different scenarios that you can find out, basically.
What are the really big trends that you see going forward? What do you expect will happen if you have to look into and be a fortune teller?
Right. So yeah, I'm looking forward to basically seeing a completely different ecosystem with lots of these really, really capable models, not only within language and vision and so on, but lots and lots of different areas. Come together and create really, really new, cool applications. At the same time, I really do feel like we're also slightly moving towards even bigger capabilities in autonomous agents with a real perception and ability to reason about the world. I think it's going to be super exciting to see the next few years.
Excellent. Then we will see what's happening. Johanna, it's starting to be to end. It's about to end this session today.
Yes, and really interesting talks by all speakers. And we also know that it has been a lot of engagement in the chat and a lot of raised hands and so on. We know that you want to take part in this discussion, and we are super happy at AI Sweden to continue the discussion offline. And also, we are working on all of the topics you heard about today. So please reach out to us if you want to contribute to what we do at broad scale in Sweden on these topics. We have several opportunities for organizations to participate and join us in our efforts to work on these topics. So please reach out and join us and keep in touch.
And thank you for participating tonight. See you some other time.